now we'll be taking up the next topic, that is the ionic product of water, right? Now you know that water, pure water is a weak electrolyte. It dissociates, yes it dissociates, but it dissociates up to a very small extent. So suppose we have the ionic equilibrium in case of water, that is the undissociated molecules and the ions formed, that is the H2O, equilibrium sign plus H and H positive and hydroxide ion, right? Or in a similar manner we can write this equation in this form also. H2O plus H2O gets dissociated to form hydronium ion plus OH negative. So either of the way you can write it, right? So the main point is that it is a weak electrolyte, therefore it is a weak electrolyte, therefore it just you can say split into or the dissociate into to a small extent. That is we get to see ionic equilibrium in between them. Now as I am writing the equilibrium constant expression, as we know if there is an ionic equilibrium we can write an expression of the ionic equilibrium. So that is what I am doing here. So K is equal to the concentration of product divided by the concentration of reactant. So this is what we have, right? Now when we multiply this H2O with K, it becomes Kw, that is the ionization constant for the water. So it is Kw is now equal to the hydrogen ion and the hydroxide ion. So this is the expression or you can say this is the ionic product of water, or this is the way we can write the ionization constant for water, right? Now what we get to see in it, right? So just keep in mind these are the important points which I am going to tell you. As we know that they get dissociated up to a very small extent, so that means the number of ions that is formed or the number of unionized molecules which are present remain almost constant. So that is approximately taken out to be the unionized molecules, you can say taken out to be 55.55 moles per liter, right? So that means this much concentration is approximately, it remains constant, that means these are the molecules which remain unionized, right? So if somebody asks you that how many molecules get ionized, so you have an expression of this, and if somebody asks you that how many molecules are remain unionized, you know that it is approximately taken as 55.55 moles per liter. How it comes out to be, 1 liter is actually taken as the 1000 gram divided by 18, that is the molecular mass of the water. It comes out to be 55.5 moles per liter. That is why we have taken this the concentration of the unionized molecules, right? Now if somebody asks you how to define this ionization constant of water, so how you are going to define it? You are going to say that yes, this ionization constant of water is directly proportional to the product of the concentration of the hydrogen ion and the hydroxide ion at a particular temperature. So as I mentioned, the term a word in a definition, that is at a particular temperature. That means this Kw value is fixed at a fixed temperature, or you can say it is constant at one temperature. So at 298 Kelvin, when we measure this value at 298 Kelvin, it comes out to be 1.00 into 10 raised to power minus 14. So this is the value which is we get at the normal temperature, that is the 298 Kelvin, right? So you should know that what is the value that they indicate, right? If we take into consideration the pure water, then what we get in case of pure water, the concentration of hydrogen ion and concentration of hydroxide ions are just same. So we take it as 10 raised to power minus 7, because we know that Kw is taken as 10 raised to power minus 14, right? So this is how you are going to take the values. Now the question must be arising that yes, this value is constant as a constant temperature. What happens when we increase or decrease the temperature? The same effect. See, it is a equilibrium constant. It is going to obey all those characteristics of the equilibrium constant. That is that with increase in temperature, the degree of dissociation is obviously going to increase. And if it is going to increase, that means this value is going to increase. And likewise, if we decrease the temperature, that means its value is going to decrease and the degree of dissociation is going to decrease. So you should know that how it gets affected with change in temperature, right? And moreover, you should know that its value remain constant at constant temperature, right? I think you are clear with it. Now what I am doing in the next you can say an example, what I am taking, what I am doing, I have taken water, right? I am adding acid to it. what I'm doing, I'm adding acid to it. So what is going to happen when I know that it is in ionic equilibrium with H positive and hydroxide ion. When I'm going to add acid into this water, that means this concentration is going to increase and this concentration is going to decrease. So how I can know about the decrease in the concentration of hydroxide ion? By the expression, as we know, this is this, and this concentration is accidentally risen because I have just added an acid to it. So the concentration of hydroxide can be known by an expression this, right? And similarly, if I add some base to it, then the concentration of hydroxide ion will increase and likewise the hydrogen ion will decrease. So if I want to know about the decrease in the hydrogen ion, I can just take the same thing, that is the Kw divided by hydroxide ion gives us the amount by which the hydrogen ions get lowered. So by these expressions we can just know that the concentration of the substance or the ion, the respective ions, which gets lowered or increased when some other substance is added to it, right? So this is the ionic product of water, and this is the just effect, you can say that what the effect it has on the ionic product of water when we add acid or base to it, right? And we do know that for pure water, as I told you, the concentration of hydrogen ion and hydroxide ion is same, that is the 10 raised to power minus 7. But when we add acid, this hydronium ion concentration just increase, and when we add base, this hydronium ion concentration just decrease. So likewise this value gets affected. So this is how we just explain the ionic product of water.